in machine learning, you have two major type of learning. One is called supervised learning, where you actually provide the result or the goal in the form of a labels. And the other one is called as unsupervised learning, while there is no result or there is no actual or ground truth. And you also have learned so far that this supervised learning you use in classification mostly. And this unsupervised learning you use clustering. Now I'm going to introduce you the third and the most modern form of machine learning, which is called as reinforcement learning. So reinforcement learning is a branch of machine learning where learning occurs via interacting with an environment. This is a very important bit because reinforcement learning is that learning where an agent actually interact with the environment, and while an agent is interacting with the environment, it learns, and based on its learning it actually decide what should be its next action. So that's what we say here. It is a goal-oriented learning where the learner is not taught what action to take. Instead, the learner learns from the consequences of its action. So this means that there is no ground truth. What is happening in the reinforcement learning is that the agent is basically learning with its failure or with the base of the reward that the environment is giving it to it. So if the environment rewards it positive, then it may happen that the agent can repeat the same action again. However, if the environment rewards it negative, then the agent may think that the action he took probably is not the right choice. So he may think to take a different action. So in a single line, you would see that a reinforcement learning basically is that learning where a learner or an agent is interacting with an environment. For example, robotics. In the robotics, a robot is an environment, and based on the environment, the action is taken, it learns and it checks whether the learning is in the right direction, and if the learning is the right direction, if it is approaching towards its goal, it may repeat the same action. However, if it finds that this action is taking it away from the goal, it may revise its action. So this is what we call as reinforcement learning. So let's take a very quick example that I will be going to display in my next slide. Here I have represent a scenario where there's a dog which has been trained by a human, and in this regard we can think that this human is acting like an environment to this dog. In this particular scenario, I will be treating dog as an agent, which is a term that is used for a reinforcement learning. Now this dog can take some actions, and based on this action, this environment can reward. The dog then observe what the rewards is, and based on this rewards, it may repeat the same action or it may change its action. So this is basically an example of reinforcement learning, that there is an agent which is basically interacting with the environment. The environment is then, based on the action taken by the agent, is rewarding, and this agent then observes what is the reward. If the reward has got a value for this agent, then it repeats the same action. However, if the reward has got a negative value for this agent, it changes its action and tries to perform an action that may give back him some positive value reward. So let's quickly recap. Reinforcement learning is a type of machine learning in which computer learns, in this case agent that we were talking about is a dog, in which computer learns to perform a task through repeated trial and error interaction with a dynamic environment. This learning approaches enables the computer to make a series of decisions that maximize a reward matrix for a task without human intervention and without being explicitly programmed to achieve the task. So as we can see that in this particular case, this dog may take a series of decision, and based on the decision, it takes different action. However, it checks its action based on the rewards that is being given by the environment, which in this case is the person. And then the dog learns which action gives him more record, and he repeats those actions. So this is an example of reinforcement learning. Okay, so now if you understand the definition of the reinforcement learning, let's quickly understand how this reinforcement learning is different from the other type of the learnings. So in this slide, I'm trying to give you an understanding between the difference of a supervised learning and a reinforcement learning. As I just mentioned to you that reinforcement learning essentially involves learning by the interaction. So this means that in the reinforcement learning, the agent or the algorithm or the computer does not know what is the right answer. Okay, and this means that there is no ground truth that that an agent knows. What it is doing is it's just interacting with the environment, and while it is interacting with the environment, it is making a series of the decisions, and based on the decisions, it either fails or pass. Now, as a result of the decision that it is taking, it then learns, and based on the value that it gets from the environment, it decides what is the best action it should do in its next attempt. So a reinforcement learning, the agent learns from its past experience, whereas it is against the supervised learning, where in the supervised learning you actually applied some kind of ground truth, and there's an external supervisor that actually provides the example. So these are two very different types of learning. In this learning, which we call reinforcement learning, there is an interaction involved. There is no ground truth involved. There is no external supervisor involved. The agent is learning by interacting. It takes some wrong steps, it takes some right steps, but based on the value or based on its success or failure, it then check itself and decide which action it has to take in its next attempt. Whereas in the supervised learning, there is an external supervisor which actually has provided what is the right answer. And all the supervised learning algorithm needs to do is it just check its output with the ground truth, and based on this, it takes a decision. So you can say that in the supervised learning, the agent knows where to go. However, in the reinforcement learning, agent does not know what is the right answer. It is just interacting and knowing the things. So I can give you a very good example about this. And the very latest example is the self-driving car. In the self-driving car, which is a very prominent case of the reinforcement learning, the self-driving car has to make some decision, and while it is on the road. So the decision it has to make is that which route to take, what is the speed of the car that it should be running. These are some major questions that the self-driving car has to perform. And the environment that where this car is moving is basically it could be a road, okay, it could be it could be a crowded place, and based on the environment, when it takes some action, it checks itself that what am I going in the right direction, and that is done or that is provided to it by a value of some value function. So in this way, the self-driving car decides that what is the next step it should follow. If I give you a same example for the simple supervised learning, the simplest example could be where you want to predict the fare from a cab going from one place to another place. So this is a kind of supervised learning, but choosing a route or the speed of the driver based on the environment where it is moving is an example of a reinforcement learning. Okay, so What are the other differences between the supervised and the reinforcement learning? So the first thing, as I mentioned, is that reinforcement learning helps you to take your decisions sequentially, and it is based on the decision style. Whereas in the supervised learning, a decision is made on the input given at the beginning. So in the reinforcement learning, the decision is in a sequential form, and the reinforcement learning is checking the environment, and based on the environment feedback, it is deciding what is the next action that should be taken. Then the reinforcement learning is working on the interacting with the environment, whereas the supervised learning works on the example or the given sample data. The best example I can give you about the reinforcement learning is playing a chess game. Because while a computer is playing a game, every moves that it uses, it checks whether this move is going to give him a positive reward, which is that whether it is able to run to win this game or not. And based on this, it decides its next move. And the best example that I can give you for the supervised learning is an in object recognition, which is a computer vision problem. So what are the challenges of the reinforcement learning? The first and the very important challenge is how the environment would teach the agent, because the only way the agent can teach is with the help of the reward. So what should be that reward, or what would be the form of the reward that gives the give or feedback the agent? So this is one of the important challenge. The another important challenge is what should be the parameter that that affects the speed of the learning. Then realistic environment that can have partial observability. So these are the three main challenges of the reinforcement learning. However, you should understand one thing, that too much reinforcement learning may lead to an overload of the state, which can diminish the result. So we have to make a compromise. The realistic environment can be or should be non-stationary. So the application that we can highlight here for the reinforcement learnings are the robotics, feedback control system, game playing, chemistry, finance sector, manufacturing, business. Out of these, control, robotics, manufacturers, these are, or the game playing, these are the hot example of the reinforcement learning. Now I am going to tell you some definition which basically reinforcement learning important system uses. So the important terms are agent. I already have given you the example of a dog. So an agent is an assumed entity which perform action in an environment to gain some reward. So in our example, for example, in this particular case where you are in this module, you are an agent, and your objective is to get the reward in terms of acquiring the highest marks in your quizzes or in your coursework. So you are an agent. Okay, the goal is to take the quiz highest marks in the quiz, and the environment is maybe the university or maybe the module leader. And based on the reaction, based on the reward from your module leader, of you actually decide your actions. So and this is an example of a reinforcement learning. As I mentioned, environment is a scenario that an agent has to face. Reward is an immediate return given to an agent on a specific action or task. State refers to the current situation written by the environment. So this means, let's take this example. Suppose you appear in a quiz. So your action is that you are appearing in a quiz. And suppose that based on your action that you perform in a quiz, you get 40% mark, which means you are now failed. So based on your action, you are in a state where you are failed. Now you will think, what should be my policy in order to pass this exam? Which means that you would decide what should be your next steps. So here comes the policy. A policy is a strategy which applies by the agent to decide the next action based on the current state. So as I have given you an example, if you are failed, then you should be thinking of policy that you should be using for your next action. And your goal is that can I come out from this current action, from this current state? Then comes the value. Value is the expected long-term return with discount as compared to the short-term reward. So the long-term return here is that you should be having your master's degree sought out. The value of function, it is specified the value of a state, that is the total amount of the reward. It is an agent which should be expected beginning from that state. So what is the model of the environment? The model of the environment actually mimics the behavior of the environment. It helps you to make an inferences to be made and also determine how the environment will behave. So then there is a model-based method. It is a method for solving reinforcement learning problem which uses model-based method. Then one more term that I would be using in my next slide is Q value or action value. A Q value is quite similar to the value. However, the difference between the two is that it takes an additional parameter as the current action. So these are the terms that a reinforcement learning algorithm would be using. Okay, so after defining these terms for the reinforcement learning, let's see what are the characteristics of the reinforcement learning, which we already have discussed a while ago. So we are just going to recap that. So the first thing that you have now realized that in the reinforcement learning, there is no supervisor. And what the algorithm is actually observing in order to decide its next action is the reward, which could be a real number. And based on this reward, the algorithm tries to improve itself. So there is no supervisor. Then the reinforcement learning basically make the decision in a sequential order, and it actually feedback by the system, and that feedback is always delayed. So with this feedback, the agent actions are determined. For example, in this figure, we have got an agent and an environment. So what happens is that agent takes an action, and then based on this action, the environment rewards it. And based on this action, the agent goes from one state to another state of that environment. And then the agent checks what is my reward. And based on this reward, it takes another action and may move to the another state. So it's basically that based on the environment reward, the agents are basically changing its action, which is bringing it into a new state. This is the basic concept of the reinforcement learning. So let's see another example where we would like to apply a cat example to understand the process of the reinforcement learning. So in this case, we have an agent, which is a cat. We have a house, which is our environment. Then a cat have two particular state. Either it is in the sitting state or in a walking state. The action that a cat can take is that it can go to either in a sitting or in the walking state. So based on this action, the environment rewards the cat, and then the cat learns what action it should be taken. So whenever the cat is exposed to the same situation, the cat executes a similar action with even more reward. So a cat learns that what to do from the positive experience and what not to do from the negative experience. So for example, the cat, which is our agent, and the state is sitting. Suppose it moves, and after moving, it moves to another state, which is a walking state. And we, as a environment, reward it with a fish. So now the cat will will understand that each time it moves, it is get a reward. So that would be a positive experience. However, if a cat does not move and keeps sitting in the same phase or in the same state, and we don't give it a reward, then this would be a negative experience for the cat. So in this way, from the experiences and the reward that is being passed from the environment to the agent learns. Okay, now very quickly, what are the reinforcement learning algorithm? In literature, there are three major types of the research of the reinforcement learning algorithms. They are value-based, policy-based, and the model-based. The value-based algorithms are those algorithms which learn the state or the state action value. In this algorithm, we estimate how good to be in a state. We take action for the next state that will collect the highest total rewards. In the value base, we do not store any explicit policy, only a value function. So in a simple way, what we do is that we evaluate what is the best state for us based on the value. For example, in our last example, the best state or the cat was a walking state, because once it is in a walking state, then it has been reward. So this is its reward function. The policy base. A policy tells us what to do from a particular state. In a policy-based reinforcement learning method, you try to come up with such a policy that the action performed in every state helps you to gain maximum reward in the future. Then, other than these two methods, we have a model-based algorithm for the reinforcement learning. In this reinforcement learning method, need to create a virtual model for each environment. The agent learns to perform in that specific environment. Now, there are different types of reinforcement learning algorithm. I just want to give you some introduction. So we have like two major types. One is model-free reinforcement learning, and the other is model-based reinforcement learning. Within the model-based reinforcement learning algorithm, the very prominent is Q-learning that I'm going to introduce you in my next slide. And in the model-based RL algorithm, there are the learn the model and given the model methods. Okay, so let's see what are the Q-learning. So other than the Q-learning method that we actually use for the reinforcement learning, it's called as Markov decision process. In a Markov decision process, once again, we are talking about the agent and an action, a state and a reward. So we have got a set of action, a set of state, a reward, a policy, and a value. And what happens is that the Markov decision process is represented by 5 important elements. A set of state the agent can be in, a set of action that can be performed by an agent for moving from one state to another, a transition probability, which is the probability of moving from one state to another state by performing some action, a reward probability, which is the probability of a reward acquired by the agent for moving from one state to another state by performing the some action, a discount factor, which controls the importance of an immediate and future reward. We will discuss this later in our next session. So what is Q-learning? Q-learning is basically a model-free reinforcement learning algorithm. And the idea is to learn quality of the action so that the agent can think what is the best action it should do in order to receive the maximum value. So what happens is that in the Q-learning model, we actually make a table, and that table could be is used to calculate out the value that agent can go in a particular state. And that value decided that what should be an agent doing to go from one state to the another state. Actually, the Q table is just a fancy name for a simple lookup table where we calculate the maximum expected future reward for an action. So what happens is we first initialize the Q table, then we choose an action, we perform an action, we measure the reward, and we update the Q table. So this is an example where we can see that how the Q table is being used. The idea is that how do we train a robot to reach the end goal with the shortest path without stepping on a mine. There will be four numbers of action at each non-edge tile. When a robot is at a state, it can either move up, down, right, or left. So let's model this environment in our Q table. In the Q table, the columns are action and the rows are states. So these are the states. For example, start state, nothing, blank state, power state, minus state, and state. So whenever it is in a start state, the functions that is defined are in columns. So in a start state, the robot can go right, it can go down, or it can go left. Similarly, there are other states which can decide about the action. Each Q table scores will be maximum expected future reward that the robot will get if it takes that action at that state. This is an iterative process as we need to improve the Q table at each iteration. And generally we use the Q learning algorithm for this. So this is basically a very quick introduction of the reinforcement learning. As you move on, we'll be going into the detail of this algorithm, giving you more insight of the mathematics. Hope it makes you a sense. And sometime later, when you go to your higher classes, you might have an opportunity to go into the detail of the Q learning algorithm.